All right, so I guess we can just get started. If you guys have video or just on unmute, I'm Jeff Brookins. I'm one of the UT PhD students. My focus is a lot on engineering, specifically metals and testing. Arlene, Stephen, would you like to introduce yourself and maybe like a focus?
I'm Arlene. I have degrees in chemistry and electrical engineering. So I'm just really mostly interested in those interdisciplinary things, the things that you can't really categorize as being a particular discipline. But I will say I'm excited about it being National Chemistry Week. I hope you're as excited as I am.
My name is Steve Trotter, and I am an environmental engineer. Work at Oak Ridge National Lab. Went to the University of Tennessee. So I am primarily interested in engineering.
All right, so I guess we can just start with the first student. If you just want to introduce yourself, John, I guess you want to go first. Just a quick bio and then what you might be interested in for science fair.
So I'm not really sure what type of engineering I'm really interested in yet. So I'm still trying to figure that out.
Have you had any science fair ideas yet?
I actually had no idea there was going to be a science fair.
Okay, that's fine. How about we move on to, is it Rajul? Rajul?
Yeah, it's Rajul.
Rajul, okay, perfect. Quick intro and a science fair project you might be interested in?
Yeah, so I'm Rajul. I'm a high school student, and then I'm interested in like computer engineering, and then I might also do chemical engineering. I'm debating between those two. And then like a science fair project that I was interested in was like creating something with like robotics and drones. I really wanted to do that.
So my hope is tonight, once we do our introductions, we can kind of talk more in depth about the projects to try and, because you guys will have to try and narrow it down pretty soon here, right? Okay. Preston, how about you?
I'm Preston. I don't really have many ideas for the science fair, but I'm thinking of something to do with testing the strength of different materials if I'm going to do anything.
You were the one last time talking about maybe like the testing speed being a factor.
I was thinking about chips. That was going to be way out of budget, but it was just a best case scenario idea.
Okay, perfect. And Kay Morgan, are you a student or a teacher?
Student.
Okay. If you'd like to go ahead.
Sure. So I didn't really know that there was a science fair. I didn't even comprehend that. But when it comes to what I like to do all things science and math. I don't really care what it is.
Okay. Are you planning on participating in the science fair at all?
Probably not.
Okay.
I like to do my own little things.
Perfect. So Arlene and Steve, you guys have done this for a few years, correct?
Yes.
Could you maybe give some like ideas of what's happened in the past for ideas or science fair projects?
Arlene, you want to go first?
Sure. I first started doing this when I was in middle school and did some science fair projects, and then helped my son and a bunch of his friends come up with science fair ideas. And then I've been, helping with judging or helping with being on the board and raising money and all sorts of things along the way. Mostly, you just need to come up with a question, because it's all about coming up with a question. And it can be something that you work with all the time. My son turned out to be an engineer, and he was interested in camping equipment and which camping equipment would do the best job of keeping the right temperature, keeping a comfortable temperature. So then you just got to set up a control, and you got to set up an experiment, and you learn something and apply something to something you like to do. So just, I did a chemistry experiment where I boiled wood and hydrochloric acid in my mother's pressure cooker. So I don't recommend that. That does not get you in good with your mother, to ruin her pressure cooker. But we're just here to kind of help you come up with ideas. And I think Preston made a good point. It's got to be in a budget that's affordable. So you don't really want to do anything that requires shipping something off to be repaired, but there's a lot you can do with household materials or with pretty simple sensors. I think sensors and measurement tools are really a cool thing to use. Things that can measure temperature or pressure. You can buy a lot of those very inexpensively and do some good, exciting stuff. And just interpreting sensors is a huge part of where I spent a career, is working with sensors and measurements. Stephen, what have you got in mind?
I think that's a perfect segue. A lot of the experiments that I have seen have focused on pollutants in the environment. And I guess Rajul mentioned something about drones, and then Arlene, you had mentioned about sensors. Maybe like using a sensor on a drone to measure the vertical distribution of a pollutant like particulate matter or ozone or pollen. That's the first thing that kind of comes to mind. I guess Preston had talked about strength of materials, and in the past I've seen a lot of experiments where students would construct a building, a model building or a model bridge, and test different forces on that bridge. So with the availability of sensors, doing something, looking at human health, blood pressure, or oxygenation of the blood, or something along those lines, measuring stress in individuals. Those are all open areas for research.
I know when I was doing science fair, Arlene, you'll be proud, I'd actually done optical gating for an electromagnetic accelerator. So instead of having mechanical or anything, we could dial it in every time it passed an optic gate, so we get maximum acceleration. And I mean, I did that with a straw magnet wire and some LEDs. So like I said, like the mentors here are pretty knowledgeable. Anyone have any just general questions? I see Kay Morgan typing a little bit. I mean, the biggest thing is just being able to tell a story, right? I mean, you always want to start with a question. That's kind of your beginning of the story. And then as you do the experiment, that kind of fills out the middle. And then the biggest trick is once you have those two, like your conclusion kind of wraps up that story into like a nice, neat little package.
And your conclusion can also say there needs to be more work on this, because most of us, when we wrote PhD theses, that's the last chapter. It's like, okay, what did we learn that we needed to still learn? And so that's an important thing, is to figure out you don't have to finish everything. And some people, especially students who are starting a science fair project in the 9th grade, say, they sometimes just sort of pick it up there and do it again, add a new angle, and just by the time they're seniors, it becomes very publishable. It can be something that you can, or I've seen people get patents too.
Yeah, that is a big one. And
any of you interested in inventing something or in getting a patent? Patents are kind of cool, because it kind of means that you've found a particular way to do something that nobody's done it that way before. And it can be really cool. And it's not impossible. I've seen a lot of high school projects that end up with patents or actually ended up selling the technology to somebody.
Yeah, especially if you get in good with sensors. Finding creative uses for especially doing something cheaper is always a good thing. So you guys can feel free to unmute. This isn't very like a formal thing. We've got plenty of time and not a whole lot of people.
So what science classes are y'all taking now? What, do you have a science teachers that can you can talk to any?
All right, Kay Morgan, you said Kennard. Is that a teacher in your school? Okay. What kind of science is it? Okay. How about John, Rajul, Preston? What kind of classes do you guys have?
Well, I'm homeschooled. I don't go to school. I don't have a dedicated teacher for science, but I just spend a lot of time looking up things on science. My dad sends me things on science stuff.
Okay. What have you been reading about?
Mostly just astrophysics, stuff like that.
Okay. I mean, there's a whole lot there that you could work on too for science fairs. A lot of low-cost telescopes have been developed, literally using off-the-shelf Home Depot parts. So if you were to do something like that and then try and like record like sky events, that's always very doable. How about, okay, John, you said you have technology as a minor and no major. What do you do in technology?
You just kind of learn about the Chromebook. It's not exactly what I expected, but it was an easy class, so I took it.
I've been there before. I think most of us may have been. Have you done any coding at all?
Yeah, I did a little bit.
Okay, I saw Preston got very, yep.
Yeah.
Let's finish off with John here. What have you done so far? Just kind of basic?
I've done some Python and Arduino and some other things.
Well, that puts you ahead of the curve. Preston, is that your flavor as well?
Yes. Arduino, Raspberry Pi, Python. That's my range too.
Okay. Rajul, what have you done?
Yeah. So I've done I'm taking AP. I took AP Bio last year, so I'm taking AP Chemistry this year. I also did like AP Computer Science.
Okay.
So
that should give you a pretty broad background then for any future work here.
Yeah.
So I can speak for myself. Arlene, Steve might be able to chime in too. For a lot of things that I do, I'm making things so that I can test other things that I've made. Like a lot of the equipment doesn't exist that I need. And knowing like Python or how to program an Arduino just to move like a small like mechatronic device, a little robotic device, has been invaluable. And I mean, I find flaws where like I don't know enough coding day to day. So having like a very early start in that definitely pays off. Arlene, Steve, do you have any coding experience?
I didn't do as much coding, but I did a lot of instrument development because I think you made a good point. A lot of us who are trying to do science, we're trying to measure something in the environment. It's not just about measuring, it's about designing something to make the measurement and to make the measurement in the place where it is. Because it's easy to measure some things in the lab, but if you're trying to measure it outside, or if you're trying to measure an existing building, somebody in the chat said something about architectural engineering. That's really intriguing. And there have been a lot of buildings over these years that have had sensors embedded in the building. So you can get some data from some of those buildings too, and do some analysis of stress on the buildings and analysis of predicting building failure and things like that. Bridges, of course, people have always watched bridges for failure modes, but we're now starting to look at buildings too. And did the sensor hold up? Can you still calibrate the sensor? Can you trust the sensor, or has it developed a flaw?
I just went through that problem with a thermocouple the other day. Didn't know if I was at the temperature I thought it was. Steve, do you do a lot of coding for the environmental side, trying to plot things out?
Primarily, I have used statistical software, SAS and JUMP. Analyzing the data from environmental measurements, trying to construct mathematical models for interpretation of that data. So that kind of limited compared to some of the students here. I mean, I've never used Python, so I could learn something from them.
Yep. Every day I wish I started Python sooner than a year ago. Morgan, do you want to talk a little bit about your math notation? If it's
Sure.
there you go.
Yep. So it's just a little project of mine where I wanted a spontaneous change at some integer x value where as x increments up by 1 or back by 1, doesn't really matter to the direction. So as x goes up by 1, so like 0, 1, 2, that means there's some function of x that has some change. So if I say if x divided by 2 has to be an element of all integers, then if it is, then do this action. If it isn't, then just put 0 instead. And as that happens, I can have points, let's say 1, -1, 1, -1. And if I put a sinusoidal or cosinusoidal wave on top, then it actually hits those points. And I was thinking, well, how could I apply this to cosine waves or sine waves or something like that? That's pretty much what I've gotten, or a symmetry value or anything else like that.
So if math is something that interests you, which it definitely sounds like it does, I mean, a lot of those are self-contained projects. We could hook you up with someone at UT who is actually a mathematician. But I mean, if you have an idea that just says, hey, this is something that I want to do, I mean, it's literally fundamental mathematics. That would be a very nice, just self-contained project you could work on.
I've also done other things besides math, but that's the main part.
Okay.
Well, you know, there are reasons to be in the science fair. It really gives you a chance to kind of gather your thoughts and do a project that's got some scope and scale. So it really looks good on your resume when you get ready to apply for colleges. And there's some decent prizes too. So I think it's worth considering the science fair as a way to spend a little time just to learn how to do a little bigger project. It's a good start because then when you get to the point where you're doing some sort of a thesis while you're, because a lot of schools now even are requiring an undergraduate thesis or a capstone project, especially engineering schools look for a capstone project. You kind of learned how to break something into pieces. You got the kernel of an idea, then you do a little research on it so you can write a little background, then you start the project, then that doesn't work. So then you start it over again. Then it finally, about the third time, it actually does what you think it's going to do. Then you write up the results. So it's more than an afternoon's work, and that's a good thing to have in your back pocket of having practice doing that.
I've always found I like outside questions as well. When someone who's not me or someone around me sees it, they can usually ask questions that, you know, may have been completely in a blind spot of mine. So I've always found that very helpful. Just as like a brief show of hands, has anyone looked at so Intel hosts like the National Science Fair, International Science Fair, ISEF, I believe it is, ISEF. Mm-hmm. Has anyone looked at the projects that have gone to ISEF? I'm guessing by the no hands, that's a no. It's a little bit of homework. It's very interesting to see what they've done. I mean, you might have an idea that kind of seems like a pie in the sky idea, like it's too big or it's too detailed, you know. Once you take a look at some of those projects, you'll realize that like, if you have a big idea, that can really put you in the running for one of those big science fairs. And I mean, especially with everything that's going on at SASIF here, I mean, with the local community ties, I don't think there's a whole lot where like if you have a question, we wouldn't be able to answer it.
Yeah, and this group, Jeff and the rest of us, can definitely help you find resources if you need some software package, or if you need to meet somebody at UT that can help you with a question you've got. We may not be able to answer it, but they can definitely help. I'll say I've been to ISEF a couple of times, and ISEF is super cool. I mean, it's a place to meet a lot of folks from all over the world, not just the US, who are interested in science and who've done fun science projects. And it's like a geek convention. It's just so fun. You wouldn't believe what fun it is.
And I mean, even as like a specific example, Preston, you said you were interested in material strength. I mean, that's something that I do on the daily. And I mean, we have the testing machines for that that'll actually pull or squeeze a sample. We have X-ray sources for diffraction to get actual information going through the sample. My office is out at Oak Ridge, and every once in a while we use neutron beam lines if we want questions that an X-ray can't answer. So I mean, the good part of being a part of like UT's thing is a lot of these resources are available to you. And it looks really good when you're going to college applications and be like, yeah, I've done a project at the spallation neutron source or at the high flux isotope reactor. It's not something that they see every day. Let's see, Morgan. I've left a lot of projects on the drawing board. I've got a whiteboard dedicated. I actually have two whiteboards. One is projects that have just kind of gone by the wayside. But the one thing I also find is I have a wall of failure. So if I've tried to make a metal alloy that doesn't work out, you know, I've got all of my conditions written on the bag, everything that I've done processing wise. And then if it doesn't work, I just hang it on the wall. And then if I try and replicate something similar to that, it has been completely beneficial to know what hasn't worked in the past. So even like as a negative result, it's been pretty good. Let me see, while we're here, I can navigate to the ISEF site for you. 1 second. Let me share my screen here. All right, so it's actually the now, can everyone see that okay?
Yeah.
Yes.
Perfect. So I said it was Intel, is actually now the Regeneron ISEF. As you can see, we've got the science competitions here, International Science Fair, and there should be the past projects. Project database. I wonder if I can just search all of them. There we go. So can everyone read those okay?
Yes.
So this is kind of what I'm saying. If you, let me go newest to oldest here. If you search through these, I mean, you'll find some pretty intense project titles. I mean, even right off the bat, we've got a pure mathematics category from 2019. This is what I'm saying, like, if you have a pie in the sky idea, try to not shy away from that. These are the ones that typically do really well and pay huge dividends later on.
So you can sort that and just go to like environmental engineering or something. And so you can, if you want to look for some ideas, it's really fun to play with the categories and pick which one you want.
There we go.
You don't have to classify your project this narrowly for here at the SACEF, but when you go to the international, they do try to box it down kind of small.
And the nice thing is you'll meet people from all over. The second project is from Poland. Does anyone have a category they'd like to see? All right, well, if not, we're gonna go to material science because that is my bread and butter. A lot of these look like they'd almost be master's level projects. Does anyone really love chemistry? I mean, that'd be ideal right now for some of these.
I like the Martian construction material there. That's pretty cool.
Yep. At my old university up at Michigan Tech, there was a laboratory that got some NASA funding to build I want to say mining robot for the moon. And as part of that, they had to have simulated lunar soil, which was always kind of interesting because then the question was like, can we build things out of this kind of soil? Because it's a little differently shaped.
Not to mention the gravity problem.
That was a huge problem. Yep. They had some very interesting shaped wheels. Yeah, biomimicry has always been a fascinating topic. It's always kind of on the up and up, is just looking at what nature did. Like, what was the most cost-effective natural design? Like, why does a crab have that shell? Why do some fish have very hard scales? And trying to draw a conclusion from like, okay, there's a fish that can withstand a piranha bite, for example. We worked on that. And as part of that, we actually looked into the scale to see what made it so strong. And it was fascinating because, I mean, it was basically a composite material. There was collagen woven all around a very stiff matrix. And I mean, we started that off just by literally getting fish scales and then looking at them. Like, it was an interesting start.
Biomaterials have done a lot for chemistry too. When you look at things like some of the glues and some of the sticky materials, and then you look at even things like spider web. Spider web is amazingly strong for the diameter. And why? So trying to create a material that mimics that.
Okay, we had a request.
Hey, Morgan just asked about logistics.
Let's see. I saw data analytics and logistics. Let's see which one pops up first. Let me know if I miss it here.
I'm sure there's data analytics in a lot of the projects. You want to just, use that as a keyword to search.
I can do that. Let's see here. All right.
Oh, wow.
Hey, right off the bat, here we go.
There's your drone enabled activity.
Yep. Steve, do you do a lot of remote sensing at all?
Not a great deal. We do a lot of sampling for radionuclides, emissions from stacks, and other pollutants, but not a great deal of remote sensing.
Okay. Do you plot that in GIS or just something separate?
We do that in GIS. Yes, we can do that.
Could you kind of talk about that a little bit? Because that's always been kind of an interesting project space.
Well, recently there has been a great deal of interest in a lot of industries and laboratories have stacks at their facilities to hopefully disperse pollutants. And we have a stack at the Spallation neutron source where we route all of our radionuclide emissions. And since about 2006, we have had dosimeters positioned at different locations on the site. And so we're very interested in looking at how the winds affect the material coming out of the stack, and where we see increased dose rates. And so we do a lot of measurements like that. And then we can take those where the stack is and the location of the detectors, and put that on a GIS overview of like Google Earth, and then start trying to see where we get peaks in higher readings. So that's some of the type of work that we're doing.
Okay. I know from things like satellite data, I've seen groups put in things like, where does it look like there's a lot of standing water, especially in like a country like Africa, and they were able to correlate that to increased mosquitoes for malaria.
Yes.
So there's a lot of like little projects out there that you're taking data that's already available, but you're looking at it in kind of a novel way.
Yes.
Let's see, do projects have any out in the field elements? Morgan, you talk about like going out and actually taking samples? Oh yeah, plenty of projects have stuff like that, especially if you're doing measurements or collecting samples. I know a lot of geology projects would do something like that. Steve's sensors, you'd have to place them all over. Do you have anything specific about it that you might be curious about?
So I was involved in a project once that was not a science fair project, but it was really interesting. It was an environmental sciences class, and we drove around all over East Tennessee measuring things. And we weren't always, sometimes we were measuring the acidity of a creek. Sometimes we were measuring how many lichens were on the north side of the tree, just trying to come up with some proxies and then mapping that back over to a map to see if we could figure out. And Bull Run Steam Plant was kind of not a good place. It was putting an awful lot of crud out that you could see reflected pretty far distanced from there. And we did one where we went to near a copper mine. So we followed the tails of a copper mine and did measurements all down through the copper mine basin. Studied that. So yeah, you can do a fairly straightforward measurement with something, pH meter, and make a really good science fair project out of it.
See, Morgan, you asked about launching a tethered balloon or deploying a benthic sampling device. For the second one, I'm assuming you mean underwater, like benthic on the bottom. Okay. Yeah, I mean, a lot of that, Steve talked about that, like being able to sample throughout a column and then being able to like spatially plot that out. Yeah, there's a lot that can be done. I've seen weather balloons used to launch cameras to basically the edge of the atmosphere. And then once that weather balloon gets, massive, it'll pop and then you can recover the camera. That's always been very interesting images. Yeah, there's a lot that can be done with tethered balloons, and especially underwater. I mean, all you have to do is just find something that you'd like, tie a rope to it, and a waterproof type sensor.
Yeah, if you want to do anything atmospheric and you want to go very high, you do have to get approvals.
Yep.
In some places.
Yeah, you should not go launching weather balloons willy-nilly.
Yeah, but and that's partly why we have the deadlines of when you have to tell everybody what your plan is. But it's definitely doable. It's definitely not a problem to do it. You just got to plan a little bit if you're going to go very far. And to get some good, interesting data, you do have to go pretty high. So you may even want to release the balloon, and just let it go on up and just not necessarily keep it tethered, which gets a different approval, but it's all approvable.
At the end of the day, it's a couple sheets of paper. And it's always easier for high school students than it is for us, where they want us to prove it.
You know, we've had some student groups around here put a lot of things, experiments into space. That's not impossible. That's, you know, sending it up to the space station or wherever. Just got to write proposals.
Were there ever any groups that did CubeSats? Like the little cube satellites?
Yep, yep. So, Preston, you need to turn your microphone on. Yeah, we've definitely had groups
Wait,
doing that.
so they were putting CubeSats in space.
Yeah, there's
Mhm,
Arlene might be able to speak more to it, but there's a few, I won't say opportunities, but definitely a few ways that you can get a CubeSat in space as a school group.
mhm.
And I mean, it is well documented. They've got, hey, this is going to be the frame that you have. You can fit everything in it that you want. So they're definitely, if that's something that interests you, there's 100% ways to do that.
Yeah, and if you can't find the information, we can certainly help you find that.
Yep, 100%. Rajul, John, you guys have been kind of quiet. Do you guys have anything, any questions?
No, not really, at least for me.
Yeah, I don't have really any questions.
Okay.
And remember, you can do team projects too. If you've got somebody that you want to work with, team projects are an option. We don't see as many in engineering as we do in the life sciences, but it's definitely within the rules.
Yep. And here's a CubeSat where it looks like they may have used it to either bounce a laser. Yep, retro reflectors. Okay. So it's there.
Actually, can you, so do you like make a project and then do you upload it to the database, like this specific database?
This database is for the International Science Fair. You'll be working off, I believe it's the
CSF
SASCF.
has a site and you have to fill, it's an online form where you say what it is you're going to do. One of the more interesting projects I ever read about, it was in the material space and the chemistry space, sort of. He was working on, the student was wanting to develop some new fireworks. Fortunately, he had a parent who worked at a firework factory up in Campbell County. So in their home garage, they were going to make fireworks. We had to get a little more approvals to that than usual because we didn't even know what we were reading about. We had to do a lot of research to figure out how safe this was. Because there actually was one of the plants up there had an explosion and a couple of people died a few years ago. We didn't want any students on a SASEF project dying. And this student did okay because the student was dealing with small quantities of reasonable explosives, but he was dealing with explosives.
How did it work out?
I didn't win, but it was the firework worked.
Okay.
The proposed firework. Mm-hmm.
So yeah, if that wasn't a good example of if you have an idea, we can work with it. I don't know what else would be. I'm trying to think of how they would have worded this. Maybe nitrogenated compounds. Nitrogen compounds.
Yeah.
How many nitrogens can you hang on a molecule? I guess. No, nothing.
Yeah, that got you. Did you just fireworks? Yeah. See if anybody's put in anything, made it to this level, the ISEF level. Nope, nothing made it to SASEF and fireworks. Yep. There aren't many places that are doing research on fireworks.
No. I remember reading about a couple it was like 2 labs that worked on high energy compounds. And I mean, it's a different type of chemistry.
Mm-hmm, mm-hmm.
Well, it looks like we have about 2 minutes left. Does anyone have any other things they want to see? Astronomical projects. Yeah, absolutely. Imaging or virtualization? Imaging. Let's see what we have here. Physics and astronomy. Yeah, the nice thing with, cameras and telescopes and everything getting cheaper, even computing power getting cheaper is.
Oh, there's some drones, cave mapping. That's cool.
Yep.
And we got a lot of caves in East Tennessee.
That is true. And there have been students and interns who have found new like celestial bodies, be it stars, comets, small planets. I mean, because a lot of it's just manpower. It's just finding the time to have someone look at it and recognize what it is.
Milky Way rotation. That's pretty cool.
I do love the homemade fiber optic gravitometer. That is a good one. Tatooine Found, as a Star Wars fan, that one, I would have voted for that one. Yeah, so there are tons of great examples on this website. If you even just poke through it. Well, do you have any final questions before I think Jason's going to pull us out here? All right. Well, I will see
Thanks,
you
Jeff.
all in the main room. Yeah, good to see everybody.
Is there
Jeff.
What was that?
computer engineering, like a computer engineering project?
Let me see if I can beat the clock here. There's computer science.
Oh yeah.
There
Yeah, I can do
is.
that. Yeah.
Okay. Yeah, because there is computer engineering.